Now, everybody, we have another really interesting talk from Mariano Cortesi from Celo, and we'll be talking about how to choose an L2. So I'd like a lovely big round of applause, please.
Hi, everybody. So my name is Mariano. I'm the head of engineering of Celo. Celo is the company behind the core development of Celo chain. And today I wanted to kind of try to talk about how to choose an L2. And I think, again, this is quite important because we are seeing nowadays that all new development happens on these L2s, and I don't think there's kind of like a good framework where people truly understand what they are actually choosing when they choose one of those. So I try to make this as simple as possible. And I'm sorry, I'm probably not going to be able to provide you many answers. The idea for me is at least to leave you with some questions. So first, I want to maybe explain what is Celo, so what I'm doing here and why I might have something to say about L2s. So Celo, it's actually a layer 1 chain. It's an EVM compatible chain that, like, around July last year, we announced our plan to transition from an L1 to an L2. And in that process, we've been actually analyzing all these different L2 frameworks, trying to analyze what are the different properties and see what actually makes sense. Now, when you go on Celo, I guess one of the most distinguished features I would say is like it's a chain that has a quite real focus on this, what I would call like real users, like non-crypto savvy users. And when you try to solve that problem, you're going to face that there's like a few of like UX problems that you need to solve. So one of the first things you're going to try to do is you're going to be able to say, okay, if I'm paying for a coffee, I need to pay with that coffee with the same currency I'm using for the coffee. So if you do, I don't know, €3 for the coffee and maybe add just a few cents for the fee, it's kind of hard to explain to someone that it's non-crypto, that you need to use some other currency, ETH, Celo, whatever, to pay for that fee. So Celo has this feature where you can actually pay with stablecoins or actually any ERC20. And we currently have, again, our own stablecoin, which is CUSD, CEuro, but we are now actually deploying USDC and USDT natively. The other thing it's going to be quite important is that you actually need to have like very low fees. Why that is important, again, also goes back to the mission of Celo. We want to help like do financial inclusion for these, where the places where this is most needed. So imagine places in Africa, places in South America, places in Asia. And to do that, you actually paying, I don't know, 50 cents for a transaction. It's actually quite a lot. So you need to try to do it like in a like much lower fee. The other thing you're going to need is also, like, it's a great mobile experience. People are actually going to be using their phones and not like high-end smartphone, just like the simplest smartphone you can imagine. And finally, you're going to also want to have this one-block finality. Again, this is something that people tend to, I guess, underestimate. When you are sending a transaction, I guess waiting 15 minutes for that to actually be finalized, it's actually quite a large amount of time that, again, for some of the things, is not really how it works. In Celo, we do like 5-second blocks, and the moment we transition to an L2, we're probably going to go to, I don't know, 2 seconds or things like that. Now, what's an L2? And again, I don't want to get very technical here. I try to explain this in a very simple way. And again, not very strict. So I would try to define them as this system where anyone should be able to derive the notion of state, of like, where's the system, by observing the L1, that is, by observing Ethereum. And they also come with what they call like a native bridge. So a way to send funds back and forth from the L1 and to L2 in a way that it's actually like what they tend to call like a validating bridge, a bridge that basically has like one of the, I guess, the best security assumptions that you can get. Now, how does these systems work or tend to work? So there's these two fellows, like there's the sequencer and there's the validator. So the sequencer is responsible to create these L2 blocks it's going to probably distribute them among like these L2 nodes out there. But more importantly, it needs to go and send the transaction data, like everything that you need to reconstruct state, to the L1. So they send like this TX data to the L1. And actually, that's enough, right? You can derive, anyone can go later, read the L1, read Ethereum, and understand, okay, I can execute all the transaction, and I can get, okay, what's the final state of this L2? Now, that's good for you to have a subjective idea of where things are, but if you want this bridge to work, you need this other part. You need to have what is called like a state commitment. A state commitment, so then you have like this validator that is going to execute the transaction from the L2, is going to get the idea of what's the state, is going to have a cryptographic commitment of that, and is going to send that to the L1. And that way, these messages back and forth of the bridge are going to be able to go. And again, there are like two flavors of that. You probably heard about that. There's like this fraud-proof or optimistic rollups, and there's like CK-proof or validity rollups. And there's, lately, maybe you've seen, there's also like a small variant of that where maybe sending data to Ethereum is too expensive, so you are trying to send data somewhere else. So you have like this other fellow called like the DA provider. You send the data there, and then you need to send the data commitment to Ethereum. That's because Ethereum is providing, I guess, what you need to know is like what is the transactions and what are the order in which I need to execute them. And this order is what we tend to call consensus, and that's what you are getting from Ethereum. By reading Ethereum, you get the order, but you don't get the data, you need to go to the DA provider. Now, why I think it is important, why we actually care about these L2s, I think this is probably like a very strong phrase here, but I guess what I'm trying to say here is like if you go and read about, I don't know, Vitalik and how the Ethereum roadmap is evolving. So Ethereum went from a model where they were thinking, we're going to have these shards, execution shards on Ethereum, and everything's going to be executed on Ethereum. And they moved from that to another model where they're saying, okay, execution is not going to happen on Ethereum. It's going to happen on these L2s, these rollups. So you probably heard about like this rollup-centric roadmap for Ethereum. What that actually means is that Ethereum is trying to be this layer where rollups go and do settlement, go and like do data availability, go and do consensus, but you don't do execution. You do the least minimal execution. Execution is always going to be expensive there. It's not the idea of the system. The idea is like you go do execution on these rollups, which means that if you are currently thinking of creating your own dApp, well, you should be thinking on like how you're going to be using maybe one of these systems. And that's what I'm trying to say here. So the problem is like, okay, you say, okay, I want to use an L2, but this is actually quite a challenge. Like you see, like not everybody here is an infrastructure engineer, so you hear all these nice terms, all these fancy technical terms, and you say, okay, CKVM, oh, that's nice, but you know there's like a type 1, 2, 3, 4 CKVMs. What's the one you want? You know that there's off-chain and on-chain data availability. Is there a difference? Is there a trade-off? You know there's validity proof, fraud proof. Vitalik has this categorization of rollup where it talks about there's like a stage 1, stage 2, stage 3, stage 4 rollup. And actually, if you go read about that, you're going to find that all of them are like stage 0 or 1. So we are pretty early. To me, this is not what you should be looking. You should be actually trying to ask yourself these kind of questions. So I guess this is an important thing. You're going to be spending all of your money, time, effort, users are going to be in this system. And you want to make sure that certain things happen. Like you want to make sure that okay, the security assumptions for these systems make sense to you, that the trust assumption makes sense, that it's cheap, that scale, that it provides a good UX, that has a good connection with all these other ecosystems. And also, probably very important, like it's a good fit for your users. This ecosystem, this place you're joining, is actually a good fit. So let me try to quickly go over this. So when you talk about security, you should be thinking about a couple of things. So funds could actually be stolen. Like you are using this bridge, you are sending things from Ethereum to the L2. But I know if there's a problem with the CK math, if there's a problem with the smart contract, is there a problem with that bridge? Well, maybe you're going to lose your funds. Or maybe not lose, but lock. So what happens if, I know, you use a centralized sequencer and the government decides to shut it down? Well, maybe then that system is unable to make progress, and if it's unable to make progress, well, we are never ever going to be able to withdraw your funds. So that's also important. And that's actually what we mean by exit freely. So I said like this, maybe a way to think about these L2 systems is like systems where you get in, you go, get your funds, send them from Ethereum to this L2, then do things, and you want to know that you can exit whenever you want without depending on anyone. And that's actually interesting to go and see. And finally, I guess, we tend to think on distributed systems and say, okay, we are thinking about malicious users, malicious operators, like kind of evil people. But in reality, there's also bugs, and bugs have actually the same effect. So it's not just thinking, oh, I don't think these fellows are going to betray me. It's like maybe they just have a bug and has the same effect. So what about trust? I think this is quite an important one. We are all here because we want to eliminate trust, or at least we want to build these systems where you don't need trust. Because if you don't mind that, go use a bank, go so traditional system, and it's going to provide like a much better UX. But if you want to do something where you don't need trust, well, that's why you're on blockchain. The problem you have is like all these systems do actually require some form of trust. And so to me, it's actually important that you contemplate that and say, okay, who am I trusting? Who do I actually need to trust here for this to behave the way I want? Do I need to trust a sequencer? Do I need to trust the validator? I guess you need to trust the company behind that, because I doubt that you're going to be reviewing every pull request, every release out there to make sure that the code is what you expect. If you are not running your own nodes, well, you're definitely going to trust this RPC provider, so also important. And why do you need trust, or what's the effect on trust? So a few things. Trust can actually, it's related to censorship. We say that we want decentralized systems because we want to avoid trust. What we want to avoid is censorship. We want to avoid that someone has the power to say, okay, this transaction goes in, but this transaction doesn't go in. And if you have a centralized sequencer, well, you have that problem. That you are trusting that sequencer not to censor. And they might censor because, I know, the government says so. And these L2 systems have another property that people think, okay, they are safe against censorship because you can do what they call forced transactions. You can go and send a transaction through an L1. And they say, okay, problem solved, no censorship. That's actually not true, I guess. Yes, you can still do that, but it's going to cost you 10x, 100x more to do a transaction, which is, in a way, a form of censorship. MEV, it's a typical one, but need to fast forward, so I guess I will talk more about the fast confirmations. Everybody loves that these L2 systems are super fast, like Ethereum produces blocks every 12 seconds. These L2 systems produce, I don't know, milliseconds, 1 second, 2 seconds. I would say, okay, this is great. Now, I explained before that you need, that you are sending the data to the L1 so that everyone can go and read that data, right? But what happens is someone gives you a confirmation and saying, okay, your transaction is done, everything is perfect, but that's actually not on the L2, on the L1. You need to wait at least 12 seconds for that to happen. So what you are actually doing there is you are trusting this sequencer to actually go 12 seconds after and submit that data. And that might not be, maybe you can trust the sequencer to do that for a coffee, but maybe for a couple of $1 million you won't. So it's also important for you to understand that. And again, I said like trust is very related to UX. UX, again, when you have trust trust in the system, well, UX is simpler. If you don't, it becomes much more of a problem. So I just talk about fast confirmations, but you need to know if like you trust them or they're good for you. Our kind of traction is a typical one. Running your own node, I think it's also important. If you want to build these systems where you want to, I guess, be decentralized, you need to make it easy for people to run their own nodes. If it's too much of a friction, that won't happen. And the other thing, I guess, is fees. So fees create friction, and friction makes UX hard. So you need to think it's actually they are scaling, no? And by scaling, you need to understand like two parts. One is like the cost. So what are the costs of this system? The system has to pay for things, has to pay for DA, has to pay for L1 transaction fees, has to pay for the sequencer, all of that, and you need to see if that actually makes sense to you. Cost and security are usually related, and so like maybe you incur more costs, but you have more security. And the other thing you need to consider is like execution or like scaling execution. People tend to think that rollups scale. Rollups are a scalability solution. That's not really true, I guess. Rollups are a scalability solution for Ethereum. Ethereum scales thanks to rollups, but a rollup itself is not really scalable. It's not something that goes much faster than Ethereum. So what you're going to see is you're going to see many rollups appearing, and you're going to see this fragmentation problem. So if you go into fragmentation, then you say, okay, can I make communication between these L2s very easy? And that's important, right? And right now, if you want to do that, you will need to go from the L2 to the L1, from the L1 to the L2. That's expensive and very slow. So what you can try to do is that maybe you've read or maybe you've heard about a few terms. You've heard about shared sequencer, which is a solution that tries to solve this problem, or you've heard about like aggregation bridges that are also trying to join to solve this problem. And this will going to create, let's say, kind of a cluster of L2s that are kind of well connected to each other. The same way like all countries within the Eurozone have better like communication and trade that they can do against, I don't know, America. I think maybe the most important question, it's probably this one, because I believe like, I guess we all love technology, but technology is an enabler. So technology tells you if something can be done or can't be done. But once it can, all technologies more or less look the same. What is more really important is like all these chains are economies, are ecosystems. And so when you are creating your product, you want to know if this ecosystem is actually good for you, it's good for your users. Do you already have users there that is going to maybe will be easier to onboard? Another thing that I think it's quite important is like all these systems are just work in progress. So you want to know if these systems are aligned to what you do, because you need to see the long game. You need to know if like these systems are going to be there in a few years or they're going to disappear. So I think I only have 30 seconds, so I'll go to the next slide. So those are the questions. I just wanted to end with this one very quick. I guess, as I said, like we're going to an L2. Why should you ever consider going with Celo? I guess I don't want to do a lot of shitting. The only thing I would say, I think for all these things, I think like the mission part is the one that occurs the most. If you are joining something, okay, you want to make sure that it's compatible with Ethereum, that it's good for UX, that you can access a lot of users through this kind of Opera Mini Pay. But most of all, you want to know that, again, they share the same vision that you have, and that's actually going to be the long game that you are playing. Okay, that's all. Thank you, everybody.